This is video number 5 for sections 3.1 and 3.2, Strange Cases and the Algebra Methods. This is the last thing we need to do. Earlier when we were doing the graphing method, we saw that occasionally you could have one of those strange things happen, like two parallel lines or two overlapping lines. Well, we need to figure out, what if we're using one of the algebra methods? How are we going to know that one of those things is taking place? So here's what I've done in letter A. I recopied the system that we used back in problem number 2. Now, when we did this before, we drew graphs on the calculator. This was the one that came out with parallel lines, and so we knew then that the answer was no solution. So we know that going in. But of course, if you just saw this on the homework, you wouldn't necessarily know that. What we'll do is, let's use, as it says here, the method of elimination, and then we'll determine how we can tell that this system has no solution. So you can look back up at the steps for the method of elimination. The preliminary step was to clear the fractions. So I'll have to take that top equation and multiply through by 2. That will make it 2y equals x plus 6, multiplying all three terms by 2. The next step is to put each equation in standard form. Remember, that means all the x's and y's on the left and the number terms on the right. So for this equation we were just working with, it looks like I just need to subtract x from both sides to make that happen. And that will give me negative x plus 2y equals 6. The second equation is already in standard form. I'll copy that down. All right, then comes that part where we use a multiplication trick, because in just a second we're going to add the equations together so that one variable will drop out. Well, this is great because, for example, I look at these x's here, and I can see that right now, if I add these two equations together, those x's are going to drop out. Let's go ahead and do that. We don't even have to use a multiplication trick. Negative x plus x, gone. Of course, then we get to the next part, 2y minus 2y. Wait a minute, that's gone too. Everybody disappeared over here. 6 plus 2 is 8. And this is when I'm left scratching my head, wondering what in the world is going on. Well, if all your variables disappear, this is the tip-off that you have one of those strange cases. This is not a situation with two lines that cross at one point. This is one of those strange cases, and you can tell that it's the one with no solution because you've gotten a ridiculous statement. You've ended with the statement 0 equals 8. That's impossible. There's no way that can ever be true. We stop and we write no solution. Remember, you either have to say no solution or you can write inconsistent system. So, letter B, how can you tell when a system will have no solution when you're using one of the algebra methods? The answer is all the variables will drop out and you will be left with a false statement. All right, let's go down to letter C. Letter C contains the system that we looked at in problem number 3. Now that was the one where we didn't even go to the graphing calculator. We had realized that the two lines were going to be overlapping, which meant that there were an infinite number of solutions. Again, you might not recognize that at first when you're using one of these algebra methods. Let's go ahead and use the method of substitution this time on this system to see what is going to happen. Again, you can go back to the list of steps. I do need to start by clearing the fractions. The first equation is fine. The second equation, I just need to multiply both sides by 4, resulting in y equals 2x plus 3. And then the next step is to take one of the two equations. We have two. We have this one, and now we have this one. And we're supposed to isolate a variable in one of the equations. Well, look at the very first equation. This y here is already isolated. That's great. That's done. Then I'm supposed to take that expression for y and substitute it in to the other equation. Well, when I do that, I'm going to write down 2x plus 3 in place of that y equals 2x plus 3. That's what was already there. Now I have an equation with only one variable in it. I'll try to solve it. Looks like I need to move some terms around. Subtract 2x from both sides. Subtract 3 from both sides. Uh-oh, I'm having the same issue as before. Over here, everybody goes out. This time, on the right, everybody goes out as well. Once again, I'm left wondering what in the world happened to all of my variables. Well, this is a tip-off that I'm dealing with one of those strange cases. And of course, you can see what the difference is. This time, instead of ending up with a false statement like 0 equals 8, I ended up with a statement that is always true. 0 equals 0. 0 is always equal to 0. This is a tip-off that you have infinite solutions. All the x's and y's on this line are solutions to the system because we must have overlapping line. My conclusion, therefore, is that I have infinite solutions. You can either write infinite solutions or you can say dependent system. Finally, letter D, how can you tell that a system will have infinite solutions when you use one of the algebra methods? Well, again, all of the variables will drop out, and you end up with a true statement.